So I'm going to talk to you about something completely different. I'm going to talk to you about Webpack bundling and module federation. And I only have 15 minutes or 14 now. So be quick. So navigating Webpack bundling is important if you start to get a bigger and bigger application. When I started, we were using, and we are still using, D-charts, high charts, some other charting library, and moment, and date functions, and PDF, and Excel, and all of that is bundled into one big application. So when you're talking about Webpack, it supports bundling. I assume all the other also support ways of bundling your stuff together. So you can't read it up here, but here it actually says there's some caching groups. There's something for Excel, for E-charts, high charts, moment, octa, date function, and then render. Render is the rest that didn't catch everything in here. And then there's, of course, our own code. So if you use Webpack, you can actually visualize it using something called Webpack Bundle Analyzer. If you put that into your plugins and say, hey, just do a static code analysis on this, you'll get a website page loading like this. And here you can see our vendor bundle has a lot of bigger jQuery, Lodash, ESN module, PDF.js, JS-zip. I don't even know what we use that for. And then we have our main application, right? So this is actually the stuff that we wrote. And then this is the vendor bundle. And then we also pulling in octa, moment, high charts, E-charts. These are both charting libraries, Excel. And then all the other ones out here, they are lazy loaded pages. So in order to load up our login screen, you need the main and you need some of the vendor bundles, whatever the main needs. So it's important to think about how you split your things into smaller pieces. And you might think, oh, we have it under control. I'm using React lazy loading, so it can do that magic for you. But then you have that one page that is lazy loaded that then imports something from another library that then imports something, and then you get everything into your main module anyway. So you need to be careful when you build this out. This can help you analyze, if I didn't do that grouping in here, in my Webpack, I would get a bundle where the vendor bundle was this big, and then the main was this big. You want to have these more or less the same size, because then the browser can download all of it at the same time. It can't load 1 million files, but it can load at least 10, 15 files at a time. So it can load all of these at the same time. So try to make sure that you think about the sizing of this. And this is an excellent tool. You just run it and then you get the answer. How does that look from my page? And the reason why we have all these out here is because it's lazy loaded. So the fact that I'm using React lazy loading, and React lazy loading is, if you look at this application out here, you could say that when I click on this menu item, then I'm loading in something in this page, right? And this page is then maybe it's this one. So it's not loaded in order to show the login screen. Then I only need the main and some of the vendor stuff. But when I click the menu button there, I ask React to lazily load this specific page, which is really nice, but it also gives some headaches. And one of the headaches is that if you think about, okay, we build everything, we have all these bundles, and we ship it to production. I then render this page on a different, this site on a different page, and then Anders goes in, does a change, and releases that to production. That means this specific page that I'm going to click on is now a different JS file, right? My browser has a version of the main where the main says, oh, you need to download version X of this lazy loaded module. Then lazy loading goes in and says, oh, I'm just going to catch we've implemented it this way. So you have a retry. So if you get any error, just reload the page because the browser has already gone to the other page. Then when you reload, it will go and get the latest main. The main will say, oh, I need the version that Anders built. And then it works. So the user doesn't see it other than, oh, when I click this magic button, it just re-renders, reloads the browser. But you don't get those irritating headaches for the user. They don't see it. And if you release every day like we do, you want that in there. Yeah, that's it for chunk loading errors. If we move on to something called module federation, it's a separate topic, but it's again, it's trying to solve some of the same benefits of this lazy loading. It's trying to decouple things. Module federation can do it, I would say, to the extreme. It has all the benefits of web performance and can build independently. So you really want to have something like module federation, which is what solves microfrontends for you. So what it does is it supplies some interfaces, you could say. So inside the host application, we'll see that in a minute, I'm able to import a button and a use store by just using a normal import, just like you're used to in NX. And this remote app / button is then pointing to, oh, remote app. So that comes from my federation package saying remote app is actually this remote entry JS file. So it's a JS file on the network. It needs to understand. Then in the remote version, I have a completely separate deployable unit over here, and I can expose some functions or code. And here I'm exposing the button and the store so that I can import it over here. So the button is just a normal React button. I'm just exposing the button here and making sure that if anyone wants to use this, they can read that from this remote entry JS. So this is like what Webpack does for us, right? It bundles stuff together for us. Now, module federation is so cool that it can understand shared libraries. So if you're on the same web page and rendering the remote app and the host app, then module federation goes in and says, oh, you asked to share the React code. Then I don't need to download the React code again and load it into the browser because it's already there. So the minute you load in this remote, it doesn't go and pull in React again, because that's really not what you want. But if it's missing, then it knows that it has it available, so it can always say, yeah, okay, it's not there yet, so I'll just load it up. So it could be Yotai, that's a library that's being used over here, but not in the host. And maybe a third version, our app is also using Yotai. So it'll just be whatever is hit first in the browser. We're just loading that library, and then we'll only have one version of it. If we look at how we do it here at Track Unit, we've implemented our own API on top of module federation. And it's complicated to cover in 5 minutes. There's a page called developer.trackunit.com if you want to read up on how it's all working. But essentially, we're trying to get to the point where we own the host out here. That's the main application. And everything that's in here is owned by you. So external companies can contribute into our application using module federation. Now I just showed you that, oh, we can share code and it's all good. And React is only going to be loaded once. And then I'm going to say we actually use iframes here. So it circumvents all that. But it doesn't circumvent it more than we want it to. So we own the iframe. In that iframe, I use module federation to load up the package that you built. That means you can build it and use our button component by importing that from my NPM registry. Then if I decide I want to make the button blue, I can just inject on that module federated page in the iframe, I can just inject a new version of the track unit button package. And then your code will not change. So as long as the interfaces are identical, I can inject stuff into this page that you built 2 years ago, and I can just update some of the code snippets using module federation. That's one thing. Let's say in 2 or 3 years, someone comes along and builds something that's even better than iframes. Not as convoluted to work with, but still isolated, because it's the isolation that we need when we're talking about external engineers building on top of our platform. So that's what we built. We've identified cases of our UI where we said, all right, here, we don't want to make it part of the host. That means our host application is not 250,000 lines of code. No, it's way less, and it starts up within 30 seconds. Once you have the host up and running, you can then say, oh, I need to build something in this specification page. All I'm going to do is start that up and get that running. The combination of the host and this specific extension points then allows you to run that locally. For external engineers, they don't have our host code, but they can run against our dev environment and say, yeah, I want to run local. And that allows them to run their code in the browser using our host application. So what is an Iris app? I told you the entry point of a module federated package is actually a JavaScript page or a JavaScript package, right? We also supply or build up this manifest. It's just a JSON document statically telling us how to render it in this application. Because the menu bar out here, we want to show instantly. We don't want, it'll just ask your code. So should I show this for this specific machine? And then it'll keep spinning for 5 minutes, and then your code returns and it says, yeah, I'm going to show it. No, we want that to be instant. So the menu can be displayed instantly. And then when you click on this specification page, which comes from the manifest, remember this is static code, just a JSON file. Then we can say, all right, when you click on specification, I'm going to load up this iframe, and then I'm going to load up your code. So again, the host is not dragged down performance-wise. We're not pulling in more than we need to. It's in an iframe, so it's isolated. So the minute you go away from this page onto another one, those resources are cleaned up. That's just another representation of more or less the same. So we have the host, which includes what we call an Iris app. It's the iframe loader. In here, the Iris app is now, in this case, it's a Fleet extension, and this is the manifest that we're building up. So the menu item has a name and an icon. We also support translation. We also have some conditions that you can put in here and say, oh, if your fleet has the brand Manitou, then show this. Or if you have Skyjack, then show this, so that we can have people pick and choose what they want in their product. And then we put it on a marketplace so that our end customer can look at that marketplace and say, yeah, I want to buy this, access to that feature, this feature. Or they can talk to consultant companies, and then they can actually go and build private stuff for them, build into this application. Do I have time for demo? No.
You have 1 minute. Otherwise, you need to fight Anders.
I'm not going to show it. I just wanted to. Yeah, I'm going to show it.
Eat the black belt.
Exactly. Yeah. We have a very short demo here, so you can't see anything. So we have the host here, which has that Vite config. Where we had that talk about, okay, we have an app that is using remote, and I'm just going to show the app real quick. So here we have the host application. It's embedding that button that we talked about before. And if I shut down the remote, I'm in the remote folder here, then the application simply doesn't work. Of course, I would have to have error handling for that, right? But let's say I keep the host running. And then I'm going to go into this and say, now the background button is red. I don't. And then I'm going to start up the remote again. So now I have a new version, and I'm refreshing the host. So I did not redeploy the host, and I'm able to remote. So using module federation, I can actually have different applications running at the same time if I just need a way to host them, right? In this very simple example, we're actually hosting a web server for the remote and another one for the host, but actually it's just the remote entry JS files that needs to be hosted somewhere and then linked together. For the track unit platform, we're using an NPM registry and deploying versions out there. So all these Iris apps, they actually just publish to an internal repo for that. And that was it. Any questions?